Okay, now another method in solving for the inverse of a matrix, especially for a 2 by 2 matrix, is the following. So consider A to be a 2 by 2, 2 by 2 matrix wherein the entries are A, B, C, D. So if A is invertible, then um, the product AD minus CB is not equal to 0. Moreover, if AD minus BC is not equal to 0, then the inverse is given as, so you have the inverse of A is equivalent to 1 over this quantity AD minus BC, which is not equal to 0, multiplied by the matrix wherein A and D are interchanged. So you have your D and A, and applying the sign opposite to your B and C. So this now will be the inverse of a 2 by 2 matrix A. Now let us discuss some of the properties of inverses. On theorem 2.8, which tells us the properties of inverse matrices, says here that if A is an invertible matrix and K is a positive integer and C is a non-zero scalar, then the inverse of A, denoted by A with the superscript -1, and we also have A raised to K, and we also have the scalar matrix CA, and the A transpose are invertible, and the statements below are true. You have the inverse of A is A, and the inverse of A raised to K is equivalent to the inverse of A raised to K. The inverse of a scalar matrix CA is equivalent to 1 over C times the inverse of A. And then the inverse of A transpose is the transpose of the inverse of A. Example, let us find the inverse of the square of a matrix. So we can actually, we're asked to find A raised to -2, and we can actually find it in two ways. Either we will have the square, either we have the inverse of A square, which should be equivalent to the square of the inverse of A. So let us apply the first technique, which is the inverse of A square. So first of all, we need to find A square. So A square will be given by, or is equivalent to 3, 5, 10, and 18. And after finding A square, we only need to find its inverse. So say the inverse of A square will be 1 all over, okay, the product of these two. That is 3 times 18 minus the product of this one, which is 10 times 5. And then multiply it, okay, multiply this 1 over 3 times 18 minus 10 times 5 with the matrix wherein we interchange 18 and 3. And then we apply the sign opposite 5 and 10. Okay? And you can just simplify that one. So simplifying, we will have, okay, you will have 9 halves, -5/4, -5 halves, and 3/4. Now another method, so we're done solving using the inverse of A square. So we can also use the other method wherein we find the square of the inverse of A. So going back to the problem on A, so what is A again? So how do we find the inverse of A? If this is A, the inverse of A will be 1 all over 1 times 4 minus you have 2 times 1. And then we multiply it with the matrix where we interchange 4 and 1 and applying the sign opposite to 1 and 2. So this one will be the inverse of a matrix. So consequently, this is 1/2. Okay, we have 1/2 multiplied by this. So we can go to, you have here 1/2, and then you have 4, -1, -2, 1, and we simply apply the scalar multiplication to come up with the inverse of A. Then we square this one and come up with the result that is similar to the earlier technique, which is the inverse of A squared. Okay? So both methods produce the same result. Now, how do we find the inverse of a product? Now, what is the theorem about the inverse of a product? If A and B are invertible matrices of order n, then AB is invertible. That is, the inverse of the product AB is the product of the inverses of B and A in this order. Now, what about the cancellation properties? If C is an invertible matrix, then the properties below are true. If AC is BC, then A is equivalent to B. We have the right cancellation property. And then we can also have the left cancellation property, which tells us that if CA is equal to CB, then A is equivalent to B.